Alright, what is up everybody? So Mr. Porkchop back here with another video. Today's video is going to be the basics of C++. As you can see from my background, I'm still in my operating systems for programmers class. Um, but there's nothing really great to go over in that. I did the one video on the virtual machine, so putting Linux in a virtual machine. So that's about all I'm going to do, I think, from that class, unless there's something interesting that I hit. But for this one, just going to go over the basics of C++. It's been a long time since I've actually done C++, and I wanted to just kind of review it. For this, I'll be using Visual Studio. It's an older version of Visual Studio, but still works perfectly fine. You guys can use whatever you want as long as the IDE supports C++. Um, yeah, if you guys want to take a second and download Visual Studio, you can do that. We're going to Once you have it installed and it's all set up, just go ahead and create a new project. Um, we're just going to do an empty C++ project. And I'm just going to call this C++ basics, I guess. Oops, if I could spell. Alright. Yeah, it's probably what we'll call it for now. That's fine. Create it. Everything I'm going to be showing you guys today is going to be coming out of this book here, C++ Programming Language, 4th edition. I don't remember when I got this book, but it's a pretty cool book. I've actually looked through it a little bit. Obviously, I haven't read the whole thing. This thing is huge, but it's a good little place to start. So what I'm going to go over in this video is going to be a short little section, just basically the basics. I'm going to go over how to create a Hello World project, which is going to be like the first project you're going to create when you start out coding. So if you haven't coded it already, you know, you'll be able to soon. My guess is if you've done any coding at all, you've probably coded it already in some language. So we're going to build that, and then I will go over types, variables, arithmetic, probably go over this. I'll read through real quick the constants and just show you the two different examples they give, and then we'll do some tests and loops. That's all I'm going to cover in this video. But if you're not familiar with C++, it'll be a great little starter video for you. So once you have your new project created here, you're going to have something similar to this, depending on what IDE you're using. We're just going to go down to this folder that says source files, and we're just going to create a new one. So I'll go ahead and add new item, and we're just going to create a CPP file. So one of these guys here. Again, depending on your IDE and what's going on here, it may be a little different for you, but basically just kind of try to figure out how to add a new file and create a new .cpp file. Once you have that, we will create our main program, which is just going to print hello world for us. Don't worry too much about the stuff that I'm putting up there for now. Just make sure that you type it in. You will need it. Every program that you have, regardless of really the language, is going to have a main method. This main method here is going to basically, it's going to be what the compiler is looking for when it runs your program. So no matter what program you have, it's always going to have one main function that the compiler looks for, and that's going to be the starting point of your project. And in here, I'm going to do this two different ways. So the first way is this double colon, and then basically cout hello world. And if you don't know why we are writing hello world, then just Google it. And then this \n, you can see on my IDE, it actually highlights it a different color. I'll kind of go over why that is. But essentially, this will be our very first program. So we have, well, let me run it real quick. I'll show you, and then I'm going to go back and I'll show you exactly what all this stuff means so you guys aren't, wondering. So once you type all this into your source.cpp file and you click the play button or whatever button you have for running, it will print out hello world. And that's pretty much it. That is your very first program. So you've created a program that prints hello world. That is the starting point. But all right, now let's go back and kind of break this down a little bit. So right here we have int, which is basically stating a type. So int stands for integer, and it's just an integer type. And the integer value returned by main, if any, is the program's return value to the system. If no value is returned, the system will receive a value indicating successful completion. A non-zero value from main indicates failure. So if you have some kind of issue, it'll give you back something. So it's a little weird when it comes to the main as far as int, but don't worry about it too much. That's basically just saying a type. This std stands for the standard library. These two colons basically tell the compiler that this command here, cout, is located inside the std namespace. After that, the literal string, or a string literal, is going to be inside of double quotes. So double quotes basically tell the compiler, hey, this is a string literal. Oh, I have a typo there. All right, and then this \n, that backslash basically tells the compiler, like, hey, this is going to be a special character. And in this case, the n special character denotes a new line. So n stands for new line after the backslash. There are other characters that you can put behind the backslash that'll do other things. Now, when I said I was going to do this a couple different ways, I was basically just going to say that std : is not necessary if you tell it ahead of time up here what namespace you're using. So if you can just do using namespace std, and then you can get rid of that std : and your program should still run no problem. There you go, still prints hello world. So yeah, now let's go into a few different things when it comes to types, variables, and arithmetic. So as I mentioned before, there are different types that you can basically initialize things as. And that is, you can do integers. So I could do integer x equals 1, and this equal sign, we'll get into actual operators a little bit later, but I just want you to understand that the equal sign in coding does not mean x equals 1. It means that x is initialized to 1. The difference being there, when you're comparing two variables, you're going to use double equals. So 2 equals is going to mean this is being compared to this one. Are they the same? And it will return a true or false value. Whereas the single equals is basically just going to say we are setting our x to the value of 1. And yeah, so that's that. You can also do a bool, which is going to be a true or false. So bool stands for a boolean. Boolean, you can do like boolean algebra and stuff like that. It's basically just like true or false. That's what it boils down to. You can only have 2 different answers, true or false. And then you can also do a character. Characters are basically just like A through A through Z. And I believe if you're going to denote it, a character, then it has to be in single quotes. So that would be your character. And then the other one that we could do is double. So a double is different from an integer. It is a number, but a double can have a decimal place. So anytime you say an integer value, it has to be a whole number for an integer value. A double, however, can be a decimal. Same thing with a float. A float is another type, which would be also a decimal. So again, those are your different types. This book actually goes into all the detail about how much space each type takes up. I don't think it's really necessary for what I'm trying to do, so I'm not going to go into all of that. I'm going to jump right over to our, basically our arithmetic. So you can do different things inside of C++ to just like addition, subtraction, multiplication, all those things you can do inside of this, and some of it's pretty straightforward. So you can do like x plus x, that's just going to add it. You can also just do like x or plus x. So if you put the plus in front of the x, that's gonna be the same thing as saying x plus x. So it's just kind of like a shorthand version of it. You can do the same thing with minus, so you can do like x minus y, or you could do minus x, which again is going to be x minus x. You can do multiplication, which is going to be an asterisk, so just x asterisk x is x times x. And I'm using x and y as basically like what we would call a variable. These names can be anything you want. They don't have to be x or y or z. You could put literally anything you want in here. You could, write your name. You could do like pork chop. It wouldn't matter. It's just like a name of whatever your variable you want. So for the rest of this, I'm just gonna keep using x and y because they're easier. Actually, yeah, I forgot to put variables here. All right. All right, so then we went over the all right, and also multiplication or division, you can just do that forward slash there. So x divided by y. And then there's also modular division. If you're not familiar with it, essentially all it does, from what I remember in my math classes, is return the remainder. So I think if you had like 10 divided by 12 and you have a remainder of 2, it's just going to give you back 2. If there's no remainder, it just gives you 0. Pretty sure that's what it is. Don't quote me on that, but from what I remember, that's what it is. And then we have comparator operators. So this is what I was getting at earlier when I talked about the double equals and the single equals. So comparator operators, you can have your equals. So you can do like x equals y, and it'll tell you like yes or no, or true or false. You can also do x not equal to y. So you would do this if you're expecting, x not to be equal to y. It would be true, and then if it is equal to y, then it'll say false. You can do, greater than. You can do less than. Well, I have those backwards. My bad. So you can have x less than y or x greater than y. And you can also add equals into those. So you could do, is x greater than or equal to y? Is x less than or equal to y? So you can do those as well. The other way that you can initialize things, other than using your equals, is you can put them into curly brackets. So instead of using the actual equal sign, you could do this, and that would be the same thing. So you're still going to be able to initialize x to the value of 1 using the curly brackets. It does mention in here that in assignments and in arithmetic operations, C++ performs all meaningful conversions between the basic types so that they can be mixed freely. And all that really is saying basically is if you have like a double and you have an integer and you want to multiply those two, you're going to get back an integer basically. If what you're putting that value into is an integer. So for instance, let's say that I have x. Well, actually, this is not right because I can't have all these being the same thing. Alright, so I lied. I'm not going to use just x and y. But anyway, point being, let's say x is my integer. If I had x times my double, which is L. So if I had those two and I wanted to hold them inside of an integer, just call it like M or something, I can do that. But what it's going to do is basically truncate the number. So it's going to multiply 2.3 times 1, and it's going to give me just 2. It's going to cut off that 0.3 because what I'm putting it into is an integer. All right. There is something here that it talks about basically not even specifying explicitly what the variable type is. So you could do auto, and then you can put whatever you want over here. It'll give you the type automatically. So if you put true here, the compiler will know because you put auto that it's a Boolean. If you put 1, then it'll know that it's an integer. If you put 1.1, it'll know that it's a double or a float. Same thing. So that is also an option. However, it basically says that there are a couple of reasons why you would use auto, and the reasons being that the definition is in a large scope where we want to make the type clearly visible to readers of our code, or we want to be explicit about a variable's range or precision, double rather than float. Yeah, using auto, we avoid redundancy in writing long type names. This is especially important in generic programming where the exact type of an object can be hard for the programmer to know and the type names can be quite long. So kind of a specific place you want to use auto. I, for one, when I wrote my program, never used auto. Everything was just explicitly given a type. So I think that would probably be the best way to go about it. All right, and then we have some incremental stuff here. So inside of loops, which we'll do a little later, probably, I don't know if I'll get to it in this video, but eventually you'll learn about loops, and inside of those, it's really good to learn to be able to increment things. So this plus plus x is basically the same as writing x initialized to x plus 1. So the reason that this is important is for loops or iterating through arrays. You can basically set a value and then you can increment it by 1 every time it loops through. So arrays, and it's getting a little off topic, but I'm going to go over this real quick. Arrays are basically just like a long list, and each value inside that list is given an index, 0 through whatever the size of the array is. So normally how this works, when you iterate through an array, you would set the index value equal to x, and then you would iterate each loop. X would get incremented, and you go to the next index of the array. So yeah, hopefully you guys understand that. If not, we'll go over it again in more detail, I'm sure, in another video. So that would be incrementing it by 1. You can also do like x plus equals y, and this would be the same as writing x initialized to x plus y. So again, this is just like a shorthand version. So if you don't want, it's just to avoid having redundancy. It's always good to try to keep redundancy out of your code, so you don't want to have to write x twice. Not to mention it can look a little confusing like that. So you can do it like this instead. You can do the same thing with minus, which again would be the same as doing that. You can also do it with multiplication, division, modular division. So all the same things apply there. The next section here is constants. They show two different examples for constants, which are basically const, and that is it means basically you're promising not to change that value. So if you put something as a constant, you're basically saying this value should never change. It's whatever I say it is, that's what it is, and it's going to be constant. This is primarily used to specify interfaces so that data can be passed to functions without fear of it being modified. The compiler enforces that promise that you made by you stating that it's a constant. Um, and then the second constant would be a constant expression, I believe is what it is. And that means to be evaluated at compile time. So compile time is when you push that little green button here, when your program starts and it builds the program, that's compile time. So constant expression is basically stating that, hey, this is going to run at compile time, or this is to be evaluated at compile time. And this is used primarily to specify constants to allow placement of data in read-only memory where it is unlikely to be corrupted and for performance. All right, I'm not going to go over too much of that. We'll go into tests and loops. So I'm just going to erase all that for now. And we're going to write a little test loop here. So when we create a method, basically we're giving it a type, and the type is going to specify what it returns. So for this, we're going to do a Boolean, which means that this method here is going to return either true or false. And inside of it, we are just going to do a print statement. And it's going to say, do you want to proceed? Yes or no. Now a question mark. And we'll have our new line. So that's going to print out into our screen basically a little prompt that says, hey, do you want to proceed? And you have to hit Y for yes, N for no. And we will create a character, which is going to be our answer. And we're just going to initialize that answer to 0 for now. And then below that, we're going to do cin. Now, cin is a command that is going to basically tell the compiler it's waiting for the user to do something. So cin for us is basically going to mean that when our program comes up and we get to this line of code, line 11, it's going to be waiting for us to tell it something. And what it's going to tell us, or what we're going to tell it, is answer. You can also notice here for the cout command, we have the arrows pointing toward the out. And for the cin command, we have the arrows pointing the opposite direction. All right. After that, we are going to do an if statement. An if statement, when you type if, it's going to give you these little brackets here. And inside those brackets, you're going to write an expression that should be answered either true or false. If it's true, then you're going to go through, you're going to go and execute whatever's in your if statement. If it's false, then it should jump over your if statement and go to the next line below it. So for us, we want to know, is answer equal to y? Because you know that the user is going to either put a y or a no. If it's a y, we want to do something. So for a y, we are going to return true. And then, like I said before, if it's not y, if it's any other character besides y, we can just return false. So now if I run this, local function definitions are illegal. I think it's because I tried to create this function inside of my actual main method. So what I'm going to do is I'm going to copy this. Actually, I'm going to cut it. We'll cut this. And we'll just paste it outside of our main method. And then I will just put it right there. Let's try that. Okay, there we go. That worked. So now it says hello world. That's still there from the main method. And it's going to say, do you want to proceed? I'm going to hit yes, enter, and then it's going to return true. Then you can press any window basically to close it. And obviously returning true or false isn't going to give you that great of a example as far as like doing things, but and now you can see I could try n, and it pretty much does the same thing, but it's going to return false. Then we're not going to see what it actually returns because we don't have anything in here. But if I did like another cout command and I just did true, like something like that. Actually, I can do the new line too, just so it looks a little cleaner. And then over here, do something like that, so it's a little more visual. Now we run it. So same thing, hello world, do you want to proceed? Yes or no. I can hit Y, hit enter, and then it's going to show true because that's my printout. And then if we did it the other way, and we did N this time, it'll say false. All right. I will go back just briefly and kind of explain what happened when I had this inside my main. Anytime and that's a good thing about the IDEs, when you're inside of these integrated development environments, that's what IDE stands for. I should have probably mentioned that earlier. Um, you'll get this little window here. You'll get some type of basically feedback when it comes to running your code. If there's something in here that it doesn't like, then it's going to give you an error, and then you can read the description of the error below and hopefully try to understand what it is that's causing the error, and then you can correct it. But you'll get better at that the more you code. For now, we'll just kind of stick with the basics here. All right, they got two more examples of these Boolean accept tests. So I'm going to erase this one for now, and we are going to just do the next example inside of this one. And for this one, actually, let me undo that because it's very similar. We're going to erase everything below the CN answer because that is, I believe, where it changes. Yeah. So here they're going to use a switch statement. So we have a switch statement, we have answer, and basically what a switch statement does is it goes through a bunch of different cases. It's kind of like doing multiple if statements, but it makes it a lot easier. So if you want to do if statements that are all related to a certain variable, in this case answer, then you can use a switch statement instead, which is a little easier. And for our switch statement here, we are going to basically give it case 1. The first case is going to be y. So what this is doing is basically saying, like, in our first case, we're going to compare answer to y. If it is y, then we will return true. And then below that, we could do another case of n, and then tell it what to return if answer is n. And then below that, we can do a default. And our default is basically just going to be a cout statement that is going to say, what do they have here? I'll take that for a no. And that'll be our default. And it's also going to return false at that point. So yeah, you can do the default, which is also going to return false, and we'll go ahead and run it. Oops, I messed something up. All right, so these are the errors I'm talking about. I'll tell you the errors. And then the cool thing about these, normally they will tell you what line they're on. So this says line 12 and 14, and it says a syntax error, missing this before return. So basically what it's saying is on line 12, and this is another thing you gotta keep in mind. Just because this is a line that it got the error on doesn't mean necessarily that that's where the issue is. It can be the line before it, or it could be many lines before it. In this case, our issue is actually on line 11. I forgot to put a semicolon after my case. And the same thing on line 13, which is why I got another error on 14. I forgot to put this semicolon um, after my case. Oh, sorry. It's not supposed to be a semicolon. It's supposed to be just a colon. All right. My bad. Sorry, guys. Bear with me here. I'll move this over a little bit so it looks a little nicer. Okay, so yeah, in the switch case, it should just be a colon, not a semicolon. But either way, those two lines were the lines where I missed. All right, so now we can do a Y or an N. And again, it's just going to shut down. If we did, oh yeah, okay. So now let's try it, and we won't pick Y or N, and then it'll give us that funny message. So this one is it says I'll take that for a no, and we get that funny little printout if we use anything other than Y or N. All right, the next section here is pointers, arrays, and loops. I'm not going to go through that today. I think this is enough for my first video. Hope you guys enjoyed this. If you're brand new to coding, I'm sure this was probably informational. But yeah, that's it. That's it for this video. I hope you guys enjoyed it. If you did, leave a comment, hit the like button, subscribe. It helps me out a lot. I have 2 more books coming in the mail. One is going to be cracking the coding interview. There's a lot of other YouTube videos out there about this book. Apparently, it's pretty good. So I'll be doing some problems out of that, I'm sure, in the future. The other program or the other book that I got is on Python. So I'm going to be doing hopefully some small tutorials like this on the basic stuff, both in Python, and I'll keep doing some C++ stuff as well as I'm sure more Java as I come up with it. But yeah, I hope you guys enjoyed it, and hopefully let me know how you guys liked this this form versus, you know, just the random videos I've been doing. If you like the more structured one, me kind of going through the textbook, let me know. It's kind of hard sometimes to keep eye contact with the camera, but you guys are probably more looking at what I'm coding anyway, so hopefully it doesn't bother you guys. Other than that, that's all I got. Have a great day.